Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the altitude of triangles. Last time, we learned about one of the basic theories of plane geometry. Today, we will learn more theorems and how to apply them to solve problems. Let us examine these triangles. Do you observe the line segment that has been drawn from the vertex? In each case, it is either perpendicular to the opposite side or to the opposite side produced. That means that the line segment is what is called the altitude of the triangle. We should note here that a triangle can have more than one line of altitude. All the altitudes of a triangle are not equal except in an equilateral triangle. The altitudes of a triangle may not intersect the opposite side to the vertex. We will now learn two new theorems. Be sure to make a note of them. Observe point O in the middle of this triangle. Do you notice that it is an equal distance away from all three vertices? This is a theorem. It states that the perpendicular bisectors of the sides of any triangle are concurrent at a point which is equidistant from the vertices of the triangle. The point where they meet is called the circumcenter. Now, we will examine this diagram. We have drawn the altitudes of the inner triangle and labeled them as D, E, and F. You may notice they are exactly the same as the perpendicular bisectors of the outer triangle. Since the previous theorem already proved that the perpendicular bisectors of a triangle are concurrent, that must mean that the altitudes are concurrent as well. This is also a theorem. The altitudes of a triangle are always concurrent. The point where they cross is called the orthocenter. Now, we will discover a theorem together, students. Observe this right-angled triangle. Please find the length of line CO, where O is the point of intersection of the perpendicular bisectors of the triangle.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I hope you were able to apply these theorems correctly. Let us solve this problem together. The first thing we must notice is that the perpendicular bisector of line CA is parallel to line CT. That means that point O is on line AT. Therefore, line AO is equal to 6 centimeters. The second theorem we learned today states that point O is equidistant from all three corners. Therefore, line CO is equal to AO. It is 6 centimeters long. Do you realize what we have discovered, students? We have stumbled upon another theorem. Angle bisectors are concurrent at a point equidistant from the sides. Good work. Now that we have learned so much about bisectors, let us look at altitude. Here we see a right triangle. We can notice that line CD is very kindly marking the altitude for us. If we make a ratio of the lines AD by CD, we will see something strange. We will see that ratio is exactly equal to the ratio of lines CD over DB. In other words, the square of the length of the altitude is the product of the lengths of the segments of the hypotenuse. This is called the altitude theorem. Be sure to make a note of it. The last theorem is the most complex. It is named for a Greek mathematician named Menelaus, who lived almost 2,000 years ago. It is better expressed in writing than in words. Remember that, like all equations, it can be reversed. So, if the product of those rations comes to -1, you know that D, E, and F must be collinear. Let us learn this theorem better with an exercise. Looking at this triangle, please prove that if DE is parallel to AB, then R times S equals 1.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to apply Menelaus' theorem? Let us work through the steps together. Given the triangle A, B, C, we can see that DE and AB are parallel. The triangle ABC must be similar to the triangle EDC. Therefore, the ratio of BC to DC is equal to the ratio of AC to EC. The length of BC is equal to the sum of BD and DC, and the length of AC is equal to the sum of AE and EC. The ratio of the sum of BD and DC to DC is equal to the ratio of the sum of AE plus EC to EC. Then the ratio of BD to DC is equal to the ratio of AE to EC. Therefore, RS is equal to the ratio of BD to DC times the ratio of CE to EA. This is equal to the ratio of AE to EC times the ratio of CE to EA. This in turn is equal to 1. Therefore, we have a problem that RS equals 1. If you managed to work through the steps of this proof, you have done very well. That is all for today's lesson, students. Now that we have studied the theorems about triangles, next time we will begin to learn about quadrilaterals. Until then, thank you, teacher. Thank you, students.